Hello, this is Dr. Matecki. The purpose of this video is to walk through the solutions to the first problem on the Unit 2 homework. This problem is all about exploring some of the many uses for the demand curve. From Principles of Microeconomics, hopefully you remember that a demand curve shows the relationship between price and quantity demanded, all else equal. So to help visualize the problem that we have here, let's start by graphing the demand function. So I like to do this by finding the x and y intercepts. So we do this by first plugging in 0 for price into the demand function and solving for quantity. So this little chart on the left-hand side here, I'm just going to put a 0 here for price. Once we plug in 0 for p here, this term goes away, and then we're left with quantity is equal to 2,000 when the price is equal to 0. So this then becomes an XY pair. So we go over 2,000 to the right and up 0 and end up at a place like this right here. Okay, so that is going to be where our function crosses the x-axis. So we can find where the demand function crosses the y-axis by doing the same sort of thing. We're going to plug in 0 for q and solve for the resulting price. So again, I'm going to put in a 0 for qd here. That kind of looks like an 8 now that I see this here. That's a q, lowercase q, qd. And so we need to find what price will make quantity equal 0. And so we can rearrange this by adding ADP to both sides and then dividing 2,000 by 80 to solve for the price. And we're going to end up getting 25 when we do that. Okay, so the ordered pair 0, 25 is 0 on the horizontal axis and up 25, and so we'll just put a point like right here. So this is $25. So since this is a linear function, we know that because there's no exponents or weird fractions or anything like that in our demand function. So 2 points define a linear demand function that we refer to as a demand curve. So one thing to keep in mind also is that when we write out a demand curve, we typically write it in this fashion where the quantity is on the left side of the equation. So quantity is a function of price. This is sort of opposite from the logic that we use in terms of the graphing. So the price plays the role of the y variable and q plays the role of the x. So there are reasons why we do that. It's been that way for a couple hundred years, and if you recall from the sort of graphs that we construct with costs and revenue and profit and all those sorts of things, it just makes a little bit more sense to graph q on the x-axis in those situations. So even though logically quantity we think of as being determined by price when we're looking at a demand curve, we graph it where price is the y-axis and q is the x-axis. So don't make the mistake of thinking that this function here is in y equals mx plus b form, because it's not. The x value is actually the one that's solved for. Okay, so now that we got that out of the way, so you might also remember from Econ 2100, Principles of Microeconomics, that the demand curve can be read two different ways. So the demand curve can be read horizontally in order to find the quantity demanded associated with any given price. So for instance, if we wanted to read it horizontally, we would say, ask the question perhaps, well, what's the quantity if the price is 10? What is the quantity demanded at a price of $10? So we can use our chart to the left here, see what happens when we plug in 10 for price in our demand function. Then we're just going to get a negative 800 here. So negative 800 plus 2,000 is going to give us a quantity of 1,200. Okay, so the demand curve, in other words, tells us that at a price of $10, our quantity is 1,200. So likewise, we can use this same sort of information to read this demand curve vertically. So in other words, instead of starting at 10 and going over to the right and dropping down to find the quantity, we can start at the quantity and then go up to the demand curve. So the height of the demand curve for any given unit, in this case the 1,200th unit, gives us the willingness to pay for that unit. So this is a measure of how much the buyer values that unit of the good. It's the value of the 1,200th unit, in other words. Okay, so notice that this is just talking about a single unit, not a total value for all 1,200 units. So we can see that in this way that the demand curve really can be thought of as a marginal benefit curve. It shows us how much each additional unit of consumption is worth to a buyer. So if we want to find the valuation of all 1,200 units, we would have to find the area under the demand curve. So think of adding up the valuation of not only the 1,200th unit, but also, the 1,199th, 1,198th, the 1,000th, the second, the third, right? So we end up having all of this area to calculate if we want to find the total value for 1,200 units. So the height of the demand curve gives us the marginal benefit, and the area under the demand curve gives us the total benefit from consumption from Q equals 0 to the relevant quantity. In this case, the relevant quantity is 1,200. Also recall the term consumer surplus. So consumer surplus is the difference between what a buyer is willing to pay and what they actually have to pay, which is normally the market price. So consumer surplus is defined as the area below the demand curve but above the market price. So in this way, the consumer surplus is the net benefit from consumption. However, we don't have a market price in this example. The shirts are being given away for free by the local government. So there is no market price, okay? So this leads us to a little bit different sort of problem here. So let me erase some of this stuff. All right, now that we have a clean demand curve here. So in this case, consumer surplus, total consumer surplus would be the entire area under the demand curve, since the price is just equal to 0. That would be if we were giving away unlimited t-shirts, then at a price of 0, people would want to consume a quantity of 2,000. Again, we can see that from our demand curve here. That's our x-intercept we talked about before. However, we don't have 2,000 shirts to give away. We only have 1,000. So the relevant quantity here is going to be 1,000. Okay, and so what we need to do then is find the associated price. So at a quantity of 1,000, we go up to the demand curve, right? And what is that price? What is the valuation of that 1,000th t-shirt from the buyer's perspective? So again, we can plug 1,000 into our demand function for quantity, solve for price, and we see that it's going to be 12.5 or $12.50. Okay. So how much are 1,000 t-shirts valued at? Well, essentially what we need to do is find the area under this curve here from 0 to 1,000, from Q equals 0 to 1,000. So we actually have two different shapes here that we need to take the area of to find that area. So the area of the first shape is this triangle. That's going to be 1/2 times base times height, which is equal to 1/2 times 1250 times 1,000. And this equals 6250 once we multiply it out. So the area of the blue part here is going to be just a rectangle, so that's the length times the width. So the length is 1,000. The width or the height is 1250. So this blue area is just going to be equal to 12.5 times 1,000, which equals 12,500. Okay, so we take both of those things together and we get the total consumer surplus from consuming 1,000 t-shirts when the price is 0 is going to be equal to 6250 plus 12,500, okay, which is equal to 18,750. Alright, so now the crux of this problem is this t-shirt giveaway worth it? So in order to answer this question, we should ask ourselves, alright, do the benefits to society, the benefits in this case accrue to consumers, do the consumer benefits outweigh the cost to society, in this case the government expenditure? So now we're simplifying a little bit because we're not really worrying about the inefficiencies caused by taxation or that sort of thing. So we're going to compare the benefits of consuming the t-shirts to the cost of providing them. So in this case, again, the area, the total benefits is the area under the curve, under the demand curve, from Q equals 0 to Q equals 1,000, which is 18,750, and the cost of the t-shirt giveaway is 15,000, right? And so in this case, the benefit is indeed greater than the cost of 15,000. So yes, it's a good giveaway. It's a project, in other words, it's a project with positive net benefit. Now, is that the best use of our tax dollars? We can't really answer that question with this amount of information, right? We don't know anything about the alternatives. However, we can say that the benefits exceed the costs, and so it does make economic sense.